So let's get started. So I'll do a little bit of an introduction, more of ask some evocative questions. Well then, what is artificial intelligence? I'll just give a couple of minutes on that. And then a jargon buster. So we'll go into some detail about AI and technical stuff. You'll probably glaze over, but don't worry. We'll try and get through it. And then some key questions to explore at the end on what's actually happening in the industry at the moment. And hopefully you might see some of it. I think the industry the construction industry, is very slow in adopting new technology. I think we're still trying to get BIM to work at the moment. I've seen a few glimmers of light on HS2, but that's about it. So, introduction then. So, start with the end in mind. Stephen Covey, let's just have a look at some of these statements. I'm not saying they're correct, but let's just have a look at them. So, cost efficiency, robotics, AI, artificial intelligence, and the Internet of Things have the potential to reduce building costs by up to 20%. Innovative tools. Engineers equipped with virtual reality goggles can guide mini robots inside buildings under construction using cameras to monitor ongoing work. Smart planning. AI optimizes the routing of essential systems like electrical wiring and plumbing, enhancing building design. That could also apply to pipelines and drainage, etc. That's been used quite a lot. Safety enhancements. AI-driven systems are being implemented to develop advanced safety protocols, monitoring real-time site interactions to prevent accidents and improve productivity. Job impact. Contrary, and picking up on Yusuf's point of 250,000 people required in the industry, contrary to concerns about job loss, AI is set to transform rather than replace the human workforce in construction. It aims to minimize errors, reduce injuries, and streamline operations. So that's a key point now. AI is meant to replace jobs, but as we go through the presentation, hopefully we can see a bit more positiveness about whether it is going to replace the jobs or not. There's a few interesting aspects to it. So I think the jury's out on whether that's the case or not. And I think everybody in this room's got a part to play as to whether or not we are going to replace jobs with AI or whether we're going to be part of the solution. Strategic investments. Construction leaders are encouraged to invest strategically in AI, focusing on areas with the highest potential impact on operations. So construction leaders investing in high technology, there's a bit of a history there, whether people believe that investing in technology, especially in the construction industry, pays off. We are always slow to adopt these things. And then industry leadership, early adopters of AI in construction will likely lead the industry, gaining both short-term and long-term advantages. Well, so those are the statements. It'd be good to understand whether you feel that we are actually on the way to achieving some of those things in the future. So what is artificial intelligence? Artificial intelligence refers to the simulation of human intelligence in machines. These systems are designed to perform tasks that typically require human intelligence. So that's the key point, human intelligence. Everybody in here have got 35, 40 years, 25 years of construction industry and knowledge in your brains. So just think of that, transferring that into the AI machine. So human intelligence, such as learning, problem solving, understanding language, and recognizing patterns. So using ChatGPT, I asked it, can you give me an image of what artificial intelligence looks like? And that's what it came up with. So quite mind-blowing, really, so that you can actually just get that out of a computer by asking it in normal language. What is AI? That's it. That's all I had to do. Bang, the image came up. Right, so the next, what I'm going to go through is just a few summaries of what the components are of AI. So an algorithm. Hands up in the room, who's heard of what an algorithm is? Right, so that's good. So it looks like the news media are letting you know. Hands up in the room, who knows what an algorithm does? Hands up in the room, who's actually done some work with algorithms? I'm looking at our vendors here. I'm hoping for you guys to be full of algorithms, but maybe not. Eh? So an algorithm, a step-by-step set of instructions or rules designed to solve a specific problem or perform a particular task. Think of it like a recipe in a cookbook. So just as a recipe tells you exactly how to prepare a dish, from gathering ingredients to cooking and serving, an algorithm tells a computer how to accomplish a task by providing a series of clear and precise steps. What are we using algorithms for? Predictive maintenance. There's a gentleman here from facilities management. Are you using algorithms in your asset management system to work out when you're going to maintain something? Yeah? Okay, so maybe a little bit of starting to think about that stuff. I mean, that is made for algorithms, the data sets that you've got. If the contractor hands over his information properly, you should have a rich set of data to be able to do that. Project planning and scheduling. Optimize project planning and scheduling by analyzing vast amounts of data, including project specifications, historical data, and real-time progress reports. Oracle Construction and Engineering, over there on my left-hand side, have managed to persuade a lot of contractors to give up their historical as-built project programs, I believe. Are you got an algorithm working on it yet? No? Safety management, that's a critical one. That's definitely one we just want to invest in. So video feeds coming in. We've got sensors in all plants, and I'll be talking about this quite extensively because I'm quite excited about this, this particular aspect. Sensors on all plant and operatives, albeit anonymized, so you don't know who it is, but you know it's an operative. It might be a steel fixer, a carpenter, etc. And creating virtual safety zones to detect operative plant infringements. That is absolutely critical, that. So we can actually monitor people going in and out of zones that are created, etc. Analyzing video feeds from surveillance cameras to detect unsafe behavior, such as workers not wearing safety gear or operating equipment. So I have a car which tells me if I pick up my phone while I'm driving, not that I do, but it will tell me within 2 seconds, and it will warn me that I'm actually not concentrating on the road. It will also recognize the fact my shutting my eyes for more than 5 seconds, and it will kick in and say you need to wake up. So those kind of technologies are out there already. It's how do we use them and how do we implement them in the construction industry. And then quality control, that's coming in drones and sprays at the moment. So algorithms are used to give a set of instructions. So what does an algorithm actually look like? Well, here's one I made earlier. I asked ChatGPT to write me an algorithm on how to make a cup of tea. It went straight away and used a programming language called Python. Does anybody know what Python is? Anybody's done Python? Python's a very powerful language for managing data, linking spreadsheet data together, and do all sorts of really clever things. You can use ChatGPT just to work it out. You don't even have to know Python. You can just ask it to do something. It will do the script, copy the script into a Python software, and it will then run the code for you and do the actions. So it gave me the script. Now I don't know what I'll do with that. Obviously, I'd need a robot tea maker. But if I had a robotic tea maker, I could then program it with that script, and it would make me a cup of tea. I also asked ChatGPT just to give me a picture of what that looked like. So that was all done in about under a minute, just by asking the system to do that. Now imagine what you would do if you put the NEC contract data set into ChatGPT or a NEC large language model and got it to interrogate it. Just hold that thought. Hold that thought. Machine learning. So this is another aspect of AI. Machine learning is a subset of AI. So it's a component that we use. So to make predictions or decisions. So predictions, that's really key, predictions. And program, going back to people manipulating the program data set. The P6 program that I used to do when I was a young engineer, when Glenn used to work for me in the old days, we used to do programs. It's just a data set. A program is a set of linked activities with complex relationships. That's all it is. It's another data dump. So machine learning, if you took all the programs in the UK for the last 35 years and were able to get the code and make them into something that a machine could learn, then you got a powerful data set in there. So it's like teaching a machine to recognize patterns and improve over time without being explicitly programmed. And I've come across in my travels around the industry in the last 4 or 5 years, the likes of HS2, I think, are getting close to it. It's taken a long time, but I've seen we're up at 6D, 5D, 4D, 3D, BIM. So we're linking BIM models to quality assurance software and linking it to the asset data set. So what that means is that we are now connecting up quality assurance information, whether it's data or documentation, linked to an asset ID, which is, I think there's 1,500 assets on HS2, of which there's about another 10,000 subcomponents coming out off the 1,500 assets. So all those connections are all being done by having standardized data, clean data, and it's all connected up. So at the end of HS2, they'll be able to click on an asset and get all that information. So that's the kind of thing that's happening at the moment. So I'm doing a lot of work with P6, and I'll go through that in a minute. So neural networks. What's that all about? Well, basically, that is the brain. That's your brain is being commoditized into an AI brain. So effectively, you've got neural networks is the description of how the brain works. So inspired by the human brain, they consist of layers of interconnected nodes that process information in a way similar to how our brains do. Example, neural networks can be used for image recognition, like identifying defects in construction materials from photos. So artificial neural networks is where we make AI work like the brain works. So, and it's based on data. So Ben was telling me at lunchtime about Martin Barnes, who the founder of the NEC contract. He ended up process mapping the contracts at the time, and he had process maps all over his bedroom, and he worked it all out. And now that's a logical approach to the contract, and that's exactly what the NEC contract is. It's simple language and it's logical, unlike other contracts. So the NEC contract is actually designed to be an AI type of contract. You know, if we look at it that way, and you put all the information that you've got on the NEC contracts, all the contracts that's ever been written under the NEC, whether it's NEC 3 or 4 or 5, if you put in all the legal cases around it against the contract that was used at the time, and you're starting to build up that massive library of data with an algorithms around it to interrogate it as if you were just asking a question, just have a think about that. How does that work? That could be instant results on all sorts of aspects of contract law. So whether you're writing a contract or whether you're looking at a potential contract conflict, and you're just asking the question, and you've got all that data in there, specifically for a specific project, we've got specific contract conditions, you've got loads of Z clauses, but you know what? You wouldn't have the Z clauses because you'd have asked your large language model to get rid of the Z clauses because they didn't make sense because they were all in conflict. Yeah? So you don't have to have Z clauses anymore. Right. So I better move on quickly. As you said it was half a day, wasn't it? So anyway, there's another picture from ChatGPT, neural networks in the construction industry. Look at that, fantastic. There's people still around. All the machines are autonomous, and there is the robot there helping to do things which other people don't want to do anymore. So natural large language processing, I'll skip this a little bit, but that's the large language models I've already been talking about. Basically, this is getting all the data from an organization, from a project, etc. So, for example, large contractors like Balfour Beatty, Kier, and the like, we've got so much data. We are data rich. We have got data. I've been collecting data for Balfour Beatty for 25 years. I've got data on all the project programs. We've got data on quality. We've got method statements. We've written for every single contract. We've got everything all sitting there. Why would that not go into one big database, and then we would do some large language, we'd do some natural language processing, we would then do some algorithms, and we can then interrogate it just by asking, I'm on this project, and let's say Blackfriars Bridge, and we've got a really difficult bridge to build. Can you just show me what method statements we've done in the last 25 years on building complex bridges over the River Thames? Bang, that's it, you'll get it straight away. The contract on Blackfriars, that Network Rail contract we used, God, that was terrible. Can we have a look at that and compare it with the contract we're looking to do on a similar project? Let's go to the NEC 4 and let's check out what Z clauses we need. So all that data, and you start manipulating it and getting into it, that's when you can do it. Robotics, the other component, we've got robotics. This particular guy, Spot by Boston Dynamics, has been used quite successfully by a contractor up in Scotland and actually used for checking things, quality checking and inspections. Another major contractor hasn't quite got it off the ground yet. We take it into schools to show kids what the future looks like. So we haven't quite got there yet. But robots will play a big part. They're coming in. You can see car manufacturing are using robots for everything, and we're doing more and more off-site manufacturing now. So they are going to be coming into play. So the components of AI and the impact of construction. So data integration, that's going to be key. Automation and efficiency. Predictive analytics, that's massive. To predict things in, especially with the program and everything else that's coming along. If we can get the P6 program, the contractual program, based on a set of data for a similar project, we can really home in and get the program right from day one. Another little slide just showing the complexity of artificial intelligence, machine learning, deep learning, and then all the impacts it has on different parts of the industry. So just quickly, I'll just flick through the last 10 questions I was going to do, but basically, accuracy of project cost estimations and budgeting and infrastructure projects. So we can analyze historical project data, look at market trends, and we can start predicting costs. We're already doing that. A lot of the big contractors have got really good databases being developed, and we're starting to analyze previous contract data. This is the key one. In Australia, they're way ahead of us with AI. This particular software pulls the P6 program, mixes it with the 3D visualization and the 3D model, and links it into all the plant labor material on site. So everybody on site is censored. The people are censored. The materials that arrive on site have got a sensor in them. The machines have got sensors. So in real time, in the office, you are watching what's happening on site because everything's moving in front of you as an avatar. So an avatar is just an item you put on an object which is being captured in using global positioning software, GIS. So everything's done in real time. So at the end of the day, when the client has changed, it's asked you to move those 5 steel fixtures off that job that was in the program to over here, you can say to that's going to cost you money. We've just been delayed. You've now disrupted the sequence of events. That is happening in Australia right now, and the guys that are running this software are 30 very experienced and competent commercial and construction guys mixed with 30 highly AI-orientated developers, and they're contracting 40 years of experience brains, and they're mixing it with AI, and they're still working on the AI wrap on this. But what they're doing here in capturing this data is phenomenal, and it's probably coming to the UK soon. But you can see the sort of reports they're getting out. It's all linked to Power BI, so you're getting a daily Power BI report every day on exactly what's happening. This is also going to be key for carbon utilization. At the moment, we're great at forecasting carbon, but we're not very good at actually finding out what carbon's doing on site on a daily basis. But I'm afraid a lot of contractors have committed to reducing 30% carbon on a lot of their projects. Once this information, this software comes in, we'll understand whether we really are going to save 30%. We might be more than we think. But this is the sort of data that you can calculate everything that's happening on site with the plant utilization, downtime, etc. Next one is risk management. So I think you can see that predictive analytics and building in all the risks that have ever happened and in analysing them, you can get good results out with risk management. This is personal to me, so I'm using project data out of the common data environment, identifying every single document and deliverable on the job, linking it to the P6 activity ID with a due date, and we're analysing it on Power BI. So we're getting to leading indicators. We're starting to see when things are starting to go wrong, and we're starting to be able to put in proper decision making before things actually go for the worst, if you like. So that's it's not quite AI, but it's starting to get data organized. Improved safety protocols. I mentioned before about creating boundaries around plant, and because you've got the link between people and plant through the sensors, and you can see where people are. Anybody moves into a boundary, a virtual boundary on site, the health and safety guy can get a notification on his phone saying someone's just infringed the boundary on the thing. So this technology can be really applied to all our projects going forward. The generative design. this is a term used by Autodesk, but basically taking hundreds and hundreds of thousands of designs, put them into a big data set, and putting an algorithm on and applying simple language, you can start interrogating design that you're going to do and ask all sorts of clever questions and get the right design very quickly. So that's coming, and there's already people doing it, but it's not fully developed yet, but it's definitely coming. And 8, nearly finished, Glenn. How can AI support better decision-making and resource allocation throughout the life cycle? Well, as I said, if we're censoring everything that moves on site, we're getting daily records. Someone mentioned about records. Mr. Earnshaw, you were mentioning about good record keeping. This is excellent record keeping. This is everything, every day, recorded and analysed, and you can just analyse it by just asking the question in simple English. That's where we are potentially right now. I'll just skip that one, but it's similar stuff. The main one, just touching on ethics. One of the things when you're designing algorithms to do all this stuff, there's something called bias, impacts of bias in algorithms. So individual people can influence how the algorithm works. And you might have heard the news, certain big companies who deliver things to your doorstep, they use bias in terms of who you are, where your postcode is, and they can actually determine how things get presented to you, et cetera, et cetera. So when you're building algorithms into these big, large language models, you need to be careful and make sure you've got controls in place to keep the ethical side of things and make sure it's not biasing any particular item. So, and also to do with GDPR as well. So finally, summary slide. What do we need to do? Construction industry faces several key challenges in implementing AI solutions. Investment and integration. So are we going to invest? Who's going to invest? Where's it coming from? Training and upskilling. This is the key. This stuff, AI algorithms and robotics and everything else, who are the people that are going to be developing this stuff? Now, the key for me is that everybody in this room, we need to get involved in this because it's your brain and your knowledge, your 35, 40 years of construction industry knowledge in contracts and everything. That needs to go into these algorithms, into these big data sets, because that's going to influence the quality of AI. If you've got, pardon the expression, certain thing in, certain thing out, if you don't get the right stuff in, it's not going to happen. Standardized data management. Everything's got to be standardized. Your data sets have got to be common coding right across the project. And we know that's not happening at the moment. So that's a really big thing. And then you've got data security. That's ramping up. In my experience last year, data security in the UK has gone through the roof. I'm seeing a lot of constraints coming in on data security. So we've got to be really on top of that. And then the industry promoting AI benefits. If we want to adopt all this technology and use AI in our industry, then we need to start really selling it and getting the investment to do it. And then obviously the ethical considerations. If you're going to go down that route, we've got to get the right people doing the programming, and we've got to put the right controls in place so we get good quality programs in our data. So that's it from me. Hopefully that's raised a few questions, but the one thing I will say, the technology is already here. It's how quickly you want to adopt it.